the extension lesson for the tangent, though this is the non-required one, but a good way to get some extra points and learn some new stuff. So a couple of things we're going to look at here. Tangents particularly useful for practical problems like this. Hypotenuses can be hard to measure, but for example, if you wanted to know the height of a tree and you couldn't really climb the tree and drop a ruler down or a tape measure down, you could mark off a number of feet away from it, and then there's devices that'll let you do this, that'll let you measure that angle of elevation to the top of the tree. And it's not hard to do. So if you knew that angle and you knew this, then you could find the height of this tree. I'm going to call that x. I don't want to call it h because hypotenuse is h. I'll just call it x. Y maybe. Let's call it y because it's a height and that's up and down. So that means opposite is y, adjacent is 90. So the tangent of 26.5 degrees is equal to y over 90 feet. And that means that when I multiply both sides by 90, the tangent of 26.5 times 90 will be y. So I go clear everything out. 26.5, find the tangent, times 90. And that tree's about 44.9 feet tall. And I never actually had to climb the tree. So that's how they can determine the height of mountains and other things that they really can't easily get to the top of. If you can measure an angle to it, what they call an angle of elevation, and there's transits and other devices that surveyors use to do that pretty easily. Here's another example of that kind of thing. So let's say you get a fast-flowing river and you need to know how far across it is. Well, you can do that without actually having to cross the river. You stand directly across from a tree or some other feature, a fence post, doesn't matter, so that you have a 9, and then you walk down the river a certain distance that you measure, 50 meters, we'll say. So you've created this right triangle. Then you use your device. The device is called a transit, for it measures angles, distances, that kind of thing. But in this case, you would measure this angle right here. You measure that to be 30 degrees. So your opposite side is the width of the river. So the tangent of 30 degrees is equal to our opposite, so we'll say r for river, over our adjacent, which we marked off is 50 meters. And so tangent of 30 times 50 will equal the distance across the river. So we'll go clear out, and we'll go 30 tangent times 50. We find that our river is about 28.9 across, whatever the meters, I guess, 28.9 meters across. With these next two, we're just going to find all the missing sides and angles again. So here I have, I really only give you one side. Let me think on this for a second. I don't think I gave you enough information, did I? No, I didn't. So I need to give you an angle here. My apologies. Let's give you this angle is 38 degrees. There we go. So, oh no, I did. I'm sorry. I didn't know this angle. I missed. This is the side I gave you. My apologies. So we don't know this angle. So I have these two sides. So I have the two legs of the right triangle. I don't have the hypotenuse. So if I was going to try to find this angle, theta, this would be the opposite side. Remember, for this side, for this angle, I mean, that would be the opposite side. This would be the adjacent. So if I use the inverse tangent, so that angle, theta, is going to be equal to the inverse tangent of the opposite side, 14, divided by the adjacent, 15. So I'll do 14 divided by 15, get an answer, and do second tangent. This angle is 43 degrees. Now, right away, you know this angle. subtract it from 90 and you're good to go. You might notice I do 90 minus that. It doesn't matter. I'm just going to ignore the negative. So it's 47 degrees. So 47 degrees here. Now I want the hypotenuse. You can use Pythagorean Theorem. Let's use sine for this angle right here. So I know that the sine of a 43 degree angle, this 43 degree angle is going to be the opposite, 14 over the hypotenuse, but I don't know. If I switch those two, the hypotenuse is going to be 14 divided by the sine of 43. So I go 14 divided by, I type 43, hit sine, not second sine, sine, hit equals, and this is 20.5. And if you wanted to double check, you could do Pythagorean Theorem, just do this squared plus this squared, and then take the square root. So you could go 14, so 14 squared plus 15 squared, take the square root, that would be the hypotenuse in this case. We could try it, 14 squared plus 15 squared equals, and then take the square root, and I get 20.5. Oops, you saw it there for a second. All right, so let's try this one. Same thing, I got two sides, so let's use it for this one. This would be the opposite, this would be the adjacent. So theta is going to be the inverse tangent of 35 over 95. That means theta, after I push the buttons, is going to be, let's see, 35 divided by 95, and then do second tangent. It's 20.2 degrees, so this one is 20.2 degrees, which would make this 60, just make sure I get that right, 69.8, so this angle here is 69.8 degrees. And our missing side, a lot of ways, we'll use Pythagorean Theorem, I guess, probably the quickest. 95 squared plus 35 squared. Get an answer, and then take the square root, and that's 101.2. You could always back it up with something, another way of finding it, just to make sure that you got everything. All right, there you go.